So in creating a right angle triangle, you're going to draw any right angle triangle. Doesn't matter which direction it's facing. This is the direction we drew this one in. I'm just going to move it down a little bit. All right, so here's our right angle triangle. We identified where the right angle is, okay? Now, the only thing you can make up in creating your own right angle triangle are two things, okay? Two things. You could make up two side lengths, or you could make up one side length and one angle, okay? You can only make up two things. If you make up more than two things, then it's not a real, it could not be an actual triangle, okay? So we're just gonna make up two things. So for this triangle, we're gonna make up two side lengths, okay? We're gonna do two side lengths. So let's say this was what? What number do you guys like for a side length? Okay, so we're gonna say this is 17. Now one thing I'll look for, okay, is that there's some semblance of scale, okay? Some semblance of scale. So if we said this was 17, okay? If we said this was 17, and we're going to do another side, the other side needs to be, like this is the shortest side. So the other side that we make up will need to be a lot longer. So which side do you want to make up? Okay, so we have a number, we said this was going to be 32, okay? These are the only two things we can make up for this triangle, okay? Everything else from this point on needs to be calculated, okay? So what do we need? We need to know the hypotenuse. This is the hypotenuse over here, okay? So what is, let's call this C because we know it's C, okay? So what is C? We're going to calculate C.
It is what?
C squared, okay, will equal 17 squared plus 32 squared, okay? So just take a second, plug this in, okay, and tell me what does C squared equal. So in your calculator, you're going to grab 17, you're going to square it, you're going to do 32, and you're going to square it. Here we're using Pythagoras' theorem. This is Pythagorean theorem. Okay, we've used the Pythagorean theorem. We're calculating what C squared is. So 17 squared ends up being 289. 32 squared ends up being 1024. You add those two numbers together, you get C squared equals 1313. Okay, so this is what C squared equals. This is what the square on this side of the triangle plus the area of the square of this side of the triangle equals the area of the square here. So to get the actual side length, so then C, what we're going to do is take the square root of both sides. So we're going to go there, we're going to take the square root of this side here, 1, 3, 1, 3. Okay, we took the square root of both sides. Okay, we took the square root of both sides. The square root of C squared is just C. Okay, the square roots cancel. And in your calculator, you're going to put in the square root of 1313. So someone try doing that. I got 36.24. All right, so then C equals 36.24. That we just calculated. All right, so this is going to be 36.24. Okay, so we figured out our side length here. It's 36.24. That is our value of C. I'm just going to move this C over a little bit more. Okay, we calculated C. It's 36.24. Okay, you're well on your way for finishing. Now we need to calculate the two angles that are left. Okay, you can choose any side. Which side do you want? Do you want this side over here, the more pointy side, or the wider side? So we have unanimously decided that it's going to be the pointy side. So there's our theta, okay? Now we're trying to calculate an angle. So as soon as we're trying to calculate an angle, we're just going to help ourselves out and write out our So here, I'm going to do this in blue. Our SOHCAHTOA. SOHCAHTOA. Okay. And you can choose either one that you want because we actually have all three side lengths. So if you want to use so sine, the sine of theta is going to equal, our so is opposite over hypotenuse. So here's our opposite, okay? And here's the hypotenuse that we just calculated, okay? So it's going to equal our opposite, which is 17 over 36.24. Okay. So in order to solve for theta, to find out what the angle is, we're going to use that sine inverse button on our calculator. This will equal the sine inverse of 17, the ratio of the two sides, 17 over 36.24. Okay. So we're going to grab our calculator. And just put in those numbers. So finding that sine inverse button, putting in sine inverse on your calculator, then 17 divided by 36.24. And depending on your calculator, you're either going to press sine inverse first and then put in this ratio, or on some calculators, you have to first do the ratio and then press the sine inverse. So make sure you're familiar with how your calculator you'll be using works. If you have any questions, ask me before the test, and you'll get a chance during the practice test as well. So being familiar with how your calculator will handle these calculations is important. I wish we had the same calculators that everyone could use, but everyone has their different ones. Some calculators give you the bracket so that you can put in 17 divided by 36. Other calculators, you have to put in the bracket if you're doing the ratio at that point, okay? So become familiar, make sure you know how to get the right answer using your own calculator, okay? So what did we do right now? We found this angle over here, okay? We found this angle over here. So now we have three sides. We used Pythagoras' theorem to find the third side. Then we used trigonometry to find one of the angles. And it's up to you. You can use trig again to find the remaining angle. There's also another way to find the remaining angle. And that is, all three angles need to add to 180 degrees. Okay? So if we're going to find this angle here, I'm going to call this angle, we haven't used this Greek letter yet, so you can use whatever letter you want. You can use A, B, C, D, whichever. You're not going to get docked anything. I'm going to use this Greek letter called alpha, which is oftentimes used for angles as well. You can use X, you can use whatever you like. Alpha. So this angle alpha is going to equal 180 degrees. 180 degrees because the sum of all three angles needs to be 180 degrees. So from this 180 degrees, we're going to subtract the 90 degree angle that we know, okay? And we're going to subtract this 27.98 angle that we just calculated. Subtract 27.98 degrees, okay? So again, using our calculator, we plug that in, okay? So we have the third angle. Being 180 degrees minus 90 degrees because it's a right angled triangle and we know this is 90, minus the angle we just calculated. Using trigonometry. It's going to equal 62.02 degrees. Okay? We have now found all the sides and all the angles of our triangle. Okay? So this triangle that we made up 17 and 32. We made up the 17 and 32. And if this is 17 and 32, the hypotenuse has to be this. The hypotenuse has to be 36.24. The angle has to be 62 0.02 degrees, and this angle has to be 27.98. Okay, so we used Pythagoras' theorem, we used trigonometry, and we used our knowledge that the sum of the interior angles of a triangle have to add to 180 degrees in order to create our right angle triangle. We also made sure visually that the sides were somewhat to scale. Okay, so we made up this shorter side being 17. Therefore, this side, which is visually longer, we made it be a longer number. Okay?